my experience, I found that magical products tend to be the result of continually peeling that onion until you really get to the crux of the problem, at which point you now understand it in a way that you can leverage what you've learned in ways to create magical experiences.
Hello and welcome to the Being an Engineer podcast. Today we are delighted to have Jim Cuseo, a seasoned mechanical engineer whose remarkable career has spanned over 2 decades, influencing the design of some of the most iconic technology products. James's journey began at the prestigious Massachusetts Institute of Technology and led him through pivotal roles at Ford, Exponent, and MagCanica, where he honed his skills in the motorsport and aerospace sectors. Next, Jim spent over a decade at Apple, where he grew to Director of Mac Product Design, overseeing the development of groundbreaking products such as the MacBook Pro and the iMac with Retina Displays. Currently, he offers his expertise to various companies through his consultancy, James Cuseo LLC, aiding them in scaling operations and enhancing product designs. Jim, thank you so much for joining us today.
Thank you very much. Thank you for that wonderful intro.
Absolutely. Well, I've been super excited to talk today. You and I met just a few weeks ago, not very long ago. We connected on LinkedIn and I looked through your profile and I was so impressed with everything that you've done. And I know for a fact that the listeners are going to get so much from this episode, just drinking from your cup of knowledge. So with that, let's start with the question I begin with at every interview, which is what made you decide to become an engineer?
All right. Well, I was the first person in my family to really excel in school. I came from a long line of mechanics and, my dad was a laborer, worked with his hands his whole life. I was the first to really, take a liking to school. So when I was in high school, I was good in sciences, especially physics. I was faced with being the first person in my family to go to college. And I had no idea what I'd study. So a guidance counselor suggested engineering. And I thought, well, my dad's a mechanic. How about mechanical engineering? Sounds like it'll be a good fit. So that's what I did. I chose mechanical engineering. And I almost didn't become a mechanical engineer because during undergrad, I found my way into a software startup. And I did that for 5 years concurrently with undergrad. But I eventually decided that, mechanical engineering is my passion. I had really taken a liking for it over those first few years of study. And I decided to go back to grad school, which is when I went to MIT and refocus on mechanical engineering. And as you said, I started out in automotive and spent some time in motorsports. And then ended up in consumer electronics sort of by accident. I didn't even realize that Apple hired mechanical engineers till a friend went to work there and he told me about his time there. And I was lucky enough to get an interview with his boss and found myself at Apple, and the rest is history.
Amazing. That's a great walk through your journey to becoming an engineer. My father also influenced me in becoming an engineer. I won't go through that because this is your interview, not mine, but it's interesting how much family has influenced people on this show to become an engineer. I wouldn't have thought that was one of the deciding factors, but it's been a pretty large factor in many engineers' journey. Speaking of Apple, where you worked, you led the design of some pretty high-profile products, the iMac and MacBook Pro series. Can you walk us through maybe like one or two of the most challenging, either creative and or technical challenges that you faced while managing these products?
Sure. Well, every program at Apple was challenging in its own way. Apple generally doesn't take on anything that's too easy. My first big challenge was the development of the Force Touch trackpad. So trackpads up to that point were relatively simple devices. It was a PC board under a piece of glass, and all of that sat on top of a mechanical switch. And if you pushed on the trackpad, it would cause that switch to buckle, and that buckling would create both the feeling of a click and close the electrical switch that signaled to the computer, hey, someone just clicked me. Well, the Force Touch trackpad was an attempt to sort of re-architect how a trackpad worked. It replaced that mechanical switch with two things. The first being a set of strain gauges, which not just measured, did you click me, but how hard are you pressing on the trackpad? And with that, you can do some very interesting things. And then once the trackpad sensed that you pressed hard enough to create a click, it actually used what we call the haptic actuator to send an impulse into the trackpad, which gave you the feeling of the click. And the really interesting thing about that was most people think when you press a trackpad, even a Force Touch trackpad, and it clicks, it's moving up and down because your finger pushes down, your brain feels something. And so your brain interprets that as it moving down. Well, in actuality, the Force Touch trackpad's haptic actuator tugs the trackpad laterally. So it's not moving up and down, but it's moving back and forth. But your brain feels motion, and because of the fact that you are pushing down, it thinks, oh, that must have just clicked down. But in fact, it's just a trick of perception. Anyway, that trackpad was my first real big challenge at Apple, and was super interesting because I get to work with some really smart subject matter experts, people who are experts in the implementation of sensors, people who are experts in the implementation of haptics. And I got my first taste of being a system engineer. You know, most people think of a system as something like the computer, and they think of the trackpad as a component. But in fact, the trackpad is a system in and of itself. It's comprised of many different subsystems, some of which I named, right? The strain sensors, the haptic actuator, and all of these have to be integrated by someone. And that was my role as the systems engineer on that program. And it was super interesting because we initially went down one path, and we had a set of, we had a method of sensing strain that worked really well in the lab. But as we began to scale it, we found that it doesn't repeat every time in a predictable way. And in fact, the sensor behaves differently on day 1 than it did on day 10 and day 100. And that wouldn't be appropriate for a consumer electronics device, which needs to behave similarly every day, day in, day out. So that was the first time in my career where we ran into a situation where we had to actually abandon that architecture and start over. And so we took what we learned and we applied those lessons into a new architecture, which is essentially what we've been shipping to this day.
That is fascinating. I guess tangential to that, when you and I first spoke, I remember you talking about how, what's the right phrase here? How detailed Apple really gets in developing some of their products. They're not just putting some beautiful industrial design onto crummy technology. The level of thought and consideration that goes into these products truly is overwhelming. Can you talk, if you have specific examples, great, but even if not, just in general about the level of thought and detail that goes into a product at Apple, and how maybe that differs from the level of thought and detail that might go into some other consumer product? Sure.
I think I might use the phrase peeling the onion, because we like to think of any problem like an onion. You know, an onion has multiple layers. You peel that first layer of skin, and there's another layer of skin beneath that, and peel that layer of skin, and there's maybe another sort of transition layer between the skin and the meat. And then you get to the first layer of the onion, and you realize there's multiple layers below that. And a technical problem is a lot like an onion in that sense. You know, you can ask yourself a technical question and pretty quickly arrive at an answer, but you begin to realize, well, that's not the whole story. And you can go deeper and deeper and deeper. And it's not until you peel that onion a few layers deep sometimes you have to get all the way to the center before you really understand the problem well enough to do really amazing things with it. And I think in my experience, I found that magical products tend to be the result of continually peeling that onion until you really get to the crux of the problem, at which point you now understand it in a way that you can leverage what you've learned in ways to create magical experiences.
Terrific. Thank you. I think I just found the intro to this episode right there.
There you go.
Well, throughout your career, you've moved into a variety of different leadership roles. Can you share any strategies that you found to be very effective as you're leading large teams? Just what have you learned there?
Sure. Well, as I reflect on my career, I realize that my success as a leader mostly boils down to the people that I was able to work with. You start by hiring really great people, and then you train them to put you out of a job someday, right? In my experience, when you've trained your people up well enough so that they're ready to take over your job, well, then you probably are ready to take the next job too. So you can all kind of step up together. And, it made me much more likely to succeed as I took these people who were, really smart, great people, and we all grew together level by level. When you have people around you that you trust, it really allows you to implement a system of what I call trust but verify. When you're running a really big organization, 100 people, multiple programs going on at any given time, at any given time, I had upwards of 15 programs. Some of those programs are systems, like the MacBook computer. Some of them were the trackpad. Those are separate programs. Even though the trackpad ends up in the computer, you do think of them as separate programs at various stages anyway. When you've got that many things going on at once, you can't be in all the details. But it is your responsibility to make sure that everything in your organization ships on time, high quality, etc. So you've got to find a way to route out all of the issues that might exist that would cause you to, miss your goals. And so my strategy was you meet with your teams on a regular basis and they bring to you, the current status of things, and you listen and you process, and then you ask like 3 to 5 questions. And if you get 3 to 5 really solid answers, you're done. The team knows their stuff. You move on to the next, your next meeting. If you get a couple of those answers that, again, it's obvious the team really hasn't peeled the onion deep enough, you've asked a question that maybe surprised them or stumped them, well, maybe you got to dig deeper in that area. And if you really don't get any satisfactory answers out of the team, then you realize, well, I've got to spend more time with this team. There's something that I haven't done to set them up for success. So, this is an area where I need to focus. And so maybe you say I can spend less time with that first team who's obviously got things under control, spend a little more time with this other team over here that, needs a little more help. And that help may not be because the team, isn't as good as that first team. It may be that they've got a much more sticky problem. The onion's way thicker, skin is way thicker. And it's very rare that these questions that I ask, it's not that I'm smarter than they are so I can ask hard questions. It's that I'm coming at it from a slightly different perspective. When you're really deep into a problem, you sometimes forget to take a step back and look around. So you don't make a connection that someone with that beginner's mindset might ask if given all this information, for the first time in a meeting. So, that's the strategy I use pretty successfully at Apple. But again, it starts with surrounding yourself with great people.
That's a very effective strategy. Like you said, as a high-level leader, you can't get into all of the details. It would take way too much time, and you just don't have that many hours in a day. But it doesn't take that much time to ask some pointed questions. And like you said, listen to and evaluate the answers you get back. And that's a very effective way of figuring out where, like you said, maybe we need to peel back the onion layers a little bit further. I love that. You mentioned the focus and kind of stepping back, right? Looking at it at a 50,000 foot level. I've heard that referred to as rubber band focus, which I think that's such a great term to capture that sentiment, right? You stretch way, way, way out, and then the rubber band pulls you way back into the details, and then you're way back out, but back and forth kind of as needed, having a rubber band focus. What kind of advice might you give to engineers who have come up kind of like you, right? Hands-on, but then they want to grow into some leadership opportunities?
Yeah, sure. First of all, a bit of a disclaimer, every organization's different, right? Apple tends to value certain things in leaders. A different company may value other things. Like, for instance, during my time at Apple, I never felt like I needed an MBA to be successful. In another organization, that may be very important for an engineering leader. So every organization's different. No one is right or wrong. But what I'm about to say comes from my experience at Apple. The first advice I'd give, an IC looking to make that transition, is to look for opportunities to understand more and more of your business as early as you can. You may have been given a certain component to own the design of, but that doesn't mean your learning has to stop there. While you are in the midst of a program with everyone else, be curious about what else is going on and learn from, your colleague may have just solved a really challenging technical problem. Okay, learn from that. Maybe you see that there's a part of the device that needs a little more attention. Raise your hand and say, I'm willing to take that on. Not necessarily because it helps you grow as an IC, but it'll do that as well. But to be a leader, you really do need a good sense for the whole landscape of whatever product you're working on. So figuring out how you can efficiently gather more and more experience as quickly as possible will serve you into that transition to leadership. One caveat though, nothing is worse than someone who comes to you, asks for more when they're not doing a great job, the thing that they're primarily responsible for. So first step, make sure your house is in order, and then look for those opportunities to add, a little bit more to your plate, a little bit more to your visibility, so that you can, collect that information. Secondly, I'll say that short of specific management training programs, people are rarely told, we're going to need a manager 6 months from now, so go learn X, Y, and Z so you're ready. What generally happens is one of two things. One, a vacancy opens up and you immediately look within your organization for who might be ready. And generally those people that are ready are those who've collected some experience, along the way. The second scenario is you see a person and they're super ready for the next thing, not because you told them to, but because they went off and figured it out. And you recognize as a leader, you need to find something for this person. So maybe you find something within your organization, or maybe you find something outside of your organization. But it's important to try to put yourself in that position to be recognized when the time arises. Because the thing with leadership is timing is sometimes a factor. We may need a leader today, but 6 months from now, we have enough leaders for a while. So you really need to be in a position to seize the opportunity when it becomes available. I'd say, I just want to back up for a second, making a point. Earlier I alluded to the fact that, leaders sort of naturally arise from within and are often products of their own initiative. I think it's important as leaders, we make sure we don't overlook people who are, would be really amazing if given the right motivations. So I don't want to sit here and tell people that it's all on you. No. It's the leader's responsibility to make sure that people who will be good leaders someday know that and are working in the right direction. But it's a two-way street. I don't think you should sit back and just wait for someone to say, this will become available 6 months from now, because that's usually not how it works. It's usually a much more dynamic thing, and you need to put yourself in the position to be ready.
Yeah, terrific. Right now, you are doing some consulting. You got your own gig going, and your focus is helping companies scale their operations. What are a few of the pitfalls that you commonly see companies trying to scale up falling into, and 1 or 2 ways for how to either avoid or overcome those obstacles?
Sure. So one of the pitfalls that I see in smaller organizations is falling into the trap of thinking, we don't have time to do that now. And then, thinking that there's going to be time to get to that later. Well, the reality is there's never more time later. Later on, you might have a few more people, but generally, the work is going to scale to consume those people too, right? So, thinking, well, we'll get to that later, it generally doesn't come to pass. What you really have to do is think real hard about, what is your North Star and how important is it that we do this thing? If it's important to our company, our brand, our business, then we need to figure out a way to make this happen. If it's not important at all, then maybe we shouldn't be thinking about it at all, right? Things like quality, things like process, and we might talk about this in a little bit, but lots of companies think, oh, we're small, we don't need process. I beg to differ. I think that small companies can take advantage of that. One other pitfall that I see small companies, startups falling into is trying to emulate another company or organization in a way that's just not appropriate for them. And a great example of this is people who go and try to start a company and become the Apple of blank. And thinking, well, especially folks that have been at Apple, right? Oh, I just worked for Apple. I'm going to go to this other company, or I'm going to start another company. I'm going to create the Apple of blank. Well, Apple can do some of the things they do because of the massive resources they have, right? The massive years of experience under their belt, the massive amounts of people in region, the operational budgets, etc. So it doesn't make sense in many cases for a small organization to try to emulate Apple, especially when it comes to matters like industrial design, right? You see a lot of people out there trying to execute anodized aluminum products with 0 gaps and offsets. And the reality is, if you don't get that perfectly, it doesn't look good. So you're better off not trying, come up with your own design language, one that is appropriate for your company, your operations, the maturity of your operation, and own that, right? Don't try to emulate somebody else. That brings me to like a meta lesson, which is, when I left Apple and joined Markforged, which is where I was until recently, I realized that I needed to put all my experience into 1 of 3 buckets. Bucket number 1 were things that I learned that could be applied anywhere, verbatim, right? Just good sound engineering principles. This concept of peeling the onion's another good one. The second bucket was things that needed to be tweaked to be appropriate for wherever I was now. Like there are things I learned about industrial design at Apple, which with the right tweaking, I can go apply that elsewhere. Aspects of how you develop a product, the product development process itself is something that with the right tweaks, I can go apply that any company, big or small. The third bucket is almost the most important. There are things that I knew I had to leave behind because they'd only work at Apple. And they would only work at the Apple that I was at during the time that I was there, meaning that the things we were doing in 2015 wouldn't have worked for Apple in 1995. And they may not work for Apple in 2030. I'm not sure. But, those methodologies had their time and place, and those are ones I just have to leave behind. Not forget them, because it's important to remember, to make sure I don't try to emulate those, but just be comfortable leaving them behind.
If you can share, what's an example of one of these things that you decided to leave behind at Apple?
So, one methodology of moving fast during the product development process is the concept of parallel paths, right? Let's say you've got a specific widget and you might execute that widget in one of three ways. In your traditional way of doing things, you might prototype each widget and you would test each widget, but you would do some extensive analysis and you'd make a decision. We're going to pick widget B. That's the best way to solve this problem today. At a company like Apple, you might decide, well, I don't have the time for that upfront experimentation. So what I'm going to do is I'm going to design and release all three of these things. And, it takes 12 weeks to tool up a hard tool and get parts off of it. So while that's going on, I'm going to do this analysis and testing that I talked about so that when those parts arrive at the factory, I know I'm going to use option B. But the day I release them, I'm not sure. And so I'm going to order bulk quantities of option A, B, and C. And during a prototype round, that may be 1,000 of each. And I'm going to go into this knowing I'm going to throw away all of two of those buckets. But what that does, it buys me some time. Well, what cost does it come at? It comes at financial cost. It costs a lot of money to tool things up. It comes up with the cost of distraction, right? It's hard for a large team to execute 3 different designs. But sometimes that's the most efficient, I'm going to put that in quotes, way of getting to an answer. When efficiency is measured in how soon can I ship the product? Now, it's the least efficient when measured by other metrics, but there are times when time to shipment is the most important thing and budgets are relatively flexible and you've got some extra headcount to spend on engineering all 3 options. So maybe that's the choice you use. Like I said, that works well at Apple. It wouldn't work well at a smaller company where your resources are more focused.
Yeah. I'm guessing what comes into play there is if you can ship something in August, the amount of revenue you'll receive so far exceeds what you would have, quote unquote, saved by taking an extra 2-3 months into, September, November timeframe to do more of a linear path, that it just makes sense to spend the extra money up front, ship on August, and start generating the revenue.
Totally. I mean, these expenditures I was referring to were sometimes, on the order of $100,000, which is a lot of money to a smaller company, but in the context of a computer program, it's a rounding error, especially when you consider that if you can ship it on, May 1st, just in time for back to school purchases, that's going to earn you quite a bit of money as compared to shipping it September 1st, where kids have already bought the computer that they're bringing to college.
Yeah, right. Okay. Well, on that topic of product development, what emerging technologies do you think are going to meaningfully impact product design and engineering, I don't know, over the next decade or so? I look back at the last 10, 20 years and 3D printing, in my view, is kind of the big one that has really changed our industry. AI, of course, is kind of everywhere right now. That probably has some influence, and there's room to grow still in 3D printing for sure. Do you have any specific thoughts on any of those topics, or just completely separate trends or technologies or patterns that might really move the needle for product development engineers?
Sure. I'm seeing an increase in online collaboration tools for mechanical design. GitHub in the software space was a tremendous boon of productivity. And I'm seeing companies trying to bring that to the mechanical design space. I design a part, and in real time, you can comment on the features and tell me this face needs to move 50 microns that way because it interferes. Or, you can say this tolerance here is unacceptable, and then I can go into my CAD program. And in some instances, they're implementing this in the CAD programs. So it's really going to make design reviews and things of that nature so much more enjoyable. The days of printing something out and redlining it, are about to change big time. I mean, they have changed for a while, but I think it's going to change at an even faster clip. I think that AI, you mentioned it, is going to be a big driver of innovation, but I think it's going to be what I call human in the loop AI, meaning, I saw this post on LinkedIn a few months ago, and someone said hardware design is about to get easy. And I thought, I don't think so, for two reasons. One, when you train your AI up, you need to train it based upon a data set, right? And if that data set is made up of the sum total of things that we've produced over the last N years, you're going to get a fair amount of good products, a fair amount of crummy products, and a fair amount of average products. And if you're training your AI to recognize patterns, well, the most common patterns are going to be in average things, right? And so is the AI going to generate just a bunch of average products? Do we want average products? I think when you think of an average product, you think about something that is used for a short amount of time that ends up in a junk drawer or landfill. And that's not the type of product that I'm interested in being a part of. I'm interested in being a part of excellent products that have longevity, that deserve, their place in your toolkit, if you will. So I think, the way in which we apply AI to hardware design, I think needs to be done very, very thoughtfully. But, no doubt it's going to improve productivity, because there are things that we do as design engineers that just take time, dimensioning a drawing, and AI can do most of the dimensioning, and then you can step in and be like, nah, I don't like the way it did it here. I'm going to fix that. And, what used to take 2 hours now takes 20 minutes. I'm ready for that future.
Yeah, you and me both. Well, let me take a very short break here and share with the listeners that the Being an Engineer podcast is brought to you by Pipeline Design and Engineering, where we don't do pipelines, but do help companies who commercialize hard goods products that are complex or difficult to manufacture. And we do this by developing advanced manufacturing processes, automated machines, and custom fixtures, complemented with product design and R&D services. Learn more about us at teampipeline.us. And today we have the absolute pleasure of speaking with Jim Cuseo. Jim, you are obviously a high-performing engineer and engineering leader, and it takes motivation to stay at the top of your game. Can you share a little bit about what motivates you and what projects or goals that you're most excited about pursuing next?
Well, I'll start by saying what I look for in any job or any role in life is to check two boxes. Box number one is, am I learning something? Box number two is, am I having fun? And fun doesn't always look like a bunch of laughs, right? Sometimes it's what we call type 2 fun, which is, it wasn't fun at the time, but looking back on it, you learned a lot and it was a good experience. And yeah, that was fun. For a lot of people, college was a little bit of type 1 and a little bit of type 2, right? But I asked myself, am I learning and am I having fun? And if those two things are happening, then the motivation comes for free, right? Because you're just jazzed to, get to work the next day and start digging that problem deeper, or, you forget that you didn't eat lunch that day because you were so focused on solving a really cool problem. So, at a high level, those are the sorts of things that motivate me. In my personal career and life, some of what's motivating me right now is, trying to take my career in a slightly different direction. I spent a bunch of time doing consumer electronics, and that was great. I learned a lot. And now I get to spend a couple years doing automation, in the form of additive manufacturing, 3D printing, and that was really cool. And so now I'm trying to figure out what's the next subject area that's really going to cause me to work through lunch because I forgot, right? And I told you earlier that I did some programming back in the day, and I'm dusting that off. Because, as we start to employ AI more and more, being the person I am, wanting to peel that onion, I want to be able to look under the hood. I want to be able to sort of better understand how these tools work so that when I go to use them, I am much more aware of their constraints, their weaknesses, so that, I'm a better informed user of that technology. So, I'm taking a Harvard computer science course and going to follow that up with their AI course. And I'm super excited about that, sort of thing where this morning I couldn't wait to get out of bed so I can crack open a laptop and take the next, online class. I'm just jazzed about learning. If you can't tell, I just love to learn.
Yeah, that's awesome. I love it. I feel the same way. I'm happiest when I'm learning something, and then you get into those states of flow, right? Where, like you said, you just forget that you didn't eat lunch or whatever it is. Mm-hmm. I have an idea for you that I actually pitched to an investor who summarily dismissed it. I still think it's a good idea, but maybe you have the skill set to take this forward. You talked about AI, you talked about programming, software background, maybe dusting that off, and you talked about these cloud-based collaboration tools. I think it would be really useful for engineering teams to have an AI design review tool where it doesn't even have to be the most sophisticated design reviews, even checking for things like, hey, this hole doesn't match up with the hole below it. It's off by 30 thousandths of an inch. Is it supposed to be that way? Or you've got an M5 screw in this hole, but the threaded hole beneath it is M4. Is that intentional? Simple things like that I still find us overlooking on occasion. I think having an AI that could look through that and identify those types of things would be really very useful for engineering teams.
I totally agree. And the good news is there are people working on this. I actually met with a company a couple weeks ago that's taking a step in that direction. And I know of a few people working on generative AI for the 3D modeling space. And a couple of my colleagues are really interested in what they call geometry detection. So being able to see something in CAD, a computer seeing something in CAD, and recognizing what it is and what purpose it holds. Yeah. It's actually a really interesting problem. And so they're people like you that are looking into that already, and I'm super excited for it. I'm there for it for sure.
Terrific. I love it. Can't wait to see that come out. You have quite a lot of experience with patents. How have you been able to identify which technologies, which designs are worthy of pursuing patents? And then how have you seen patents influence the landscape of technology sectors?
Yeah, that's a great question. Patents are kind of interesting because at the end of the day, patents are really hard to defend successfully. Don't get me wrong, there's tons of examples of it, but patents are, they're tricky to write well. They're tricky to defend well. They cost a lot of money either way. So, as you said earlier, deciding whether or not something deserves a patent isn't super straightforward. Of course, you got to ask yourself the question of, is there novelty there? Like, I think it's in the definition of a patent. Have I uncovered something that is not obvious to someone skilled in the art? And you'll see a lot of patents that seem kind of obvious, but if you look real deeply at the claims, you realize like, oh no, there is a subtle tweak to a convention, which led to something being patentable. But it's a tremendous amount of time and money to create a patent. And you've got to ask yourself, as an inventor, does it make sense? Apple patents a lot of things, smaller company. And that's because, Apple has big legal teams that can help with that process. But as a smaller team, you really got to think hard. Do I want to invest the time and effort into patenting something when, in many cases, patents also sometimes give you the hints on how to engineer around them, right? It's right there in the claims. A patent is a big, long document, but really what matters is what is claimed. And that's the crux of a patent. Sometimes you decide as an organization that you don't want to patent something, but instead you're going to take a different route, which is called trade secret. In a patent, you are publicly disclosing to the world, here's what I'm doing and how I'm doing it. And by the way, that patent is only, valid in the United States or wherever it is you happen to apply for one. You can apply in various geographies, but, it's not necessarily valid everywhere, and it's much harder to defend elsewhere as well. So you may decide that rather than patent and literally tell the world how I'm doing this thing, instead we're going to keep it trade secret, which of course you no longer have the protections of the government should someone else figure out your trade secret, but you also don't have to then disclose that trade secret because the other side of a patent is it's only good for 17 years, right? And after that expires, well, now you've disclosed how you're doing something to the world. So it's, it's not obvious. At Apple, I was privileged to be a part of many really cool patents. Not as many as some of my colleagues. I have colleagues that are in hundreds of patents. I had a smaller number, but the ones I do have, I feel really proud about. But ultimately to me, as an engineer, I don't really care if something is patented. I care if it's out there being used. Because what you find is a lot of patents are just that and only that. They never actually turn into products. So there's a couple different ways of looking at them. But certainly there are super valuable in certain circumstances.
Yeah. As you're speaking about this, I thought of an analogy that may or may not be interesting, but I'll share it anyway because I'm the host and I can say what I want to say. I was thinking about jiu-jitsu. I do Brazilian jiu-jitsu and I'm a purple belt right now. And sometimes I think to myself, I don't really care that much about the belt. What I really care about is what can I do? How well can I defend myself? How well can I progress myself against my component? And I think patents are in a way kind of similar. Like they're nice. They're a recognition that you've done something important, but at the end of the day, what really matters is what you can do, right? Not how many patents you have against your name. Total tangent there. So getting back to our interview, what are a couple of areas that you have commonly seen engineering teams' progress slowed by what I'll call unforced errors? So these are not errors that were quote unquote forced by leadership swooping in and saying, hey team, instead of this being due in 6 months, it's now due in 2 months. And the whole team starts working way faster than they should. And as a result, they start making all these mistakes and errors. That's not what I'm referring to. So unforced errors in the course of just your normal development project, what are some areas where you've seen teams progress slow because they're just making mistakes that there's no reason they should have made that mistake?
Sure. I'll give you 2 examples, and they're related. And the first example has to do with going back to that sort of the paradigm that on a program, on a product like a computer, you have multiple subsystems in the computer, right? So you sit down and you define the requirements for the computer. And let's say your job isn't to design the computer, but it's to design the trackpad, right? Well, the first step of your design process should be, well, let's look at the definition of the computer and let's try to intuit from that, or let's try to look verbatim. What aspects of that definition affect me as the owner of the trackpad? Very often, engineers won't even do that. And then they'll get 6 or 8 months down the line and they'll have the first prototype and they'll go to integrate and they realize that it's not meeting a certain criteria. And they realize, oh, I missed this requirement way back here at step 1. So that's sort of unforced error. Let's call it 1A. 1B would be, you can't just look at the requirements of the computer verbatim, but you then need to intuit, what do these suggest for the requirements for my particular subsystem? So computers may be a bad example because there's so many requirements, but if you think of something, I don't know, more simple, maybe the subject is a little more meaningful, but let's say your high level product has 10 requirements and 2 of those requirements applied directly to your subcomponent. Well, those aren't the only 2 important things you need to worry about. You need to then create your own, what's called a PRD, product requirements document, for your subsystem. Thoroughly define all of the metrics of success by which you're going to evaluate, have I met my goals? And you won't catch all of them. We all miss some, right? No engineer has ever gotten to the end of a program and said, oh, nope, I thought of everything on day 1. That'll never happen. But it's also equally frequent that engineers don't sit down in the early stages and really write down everything that they are trying to achieve. Not just what are they trying to achieve, but how are we going to measure it? And what is our metric of success? If we are going to measure, capacity of the battery, what is the lower threshold below which your battery no longer meets this criteria? So that's 1B. And then the second thing is, okay, now that you have these criteria and you prototype a couple of devices, 10, 20, 100, 1,000, whatever it is, and you've measured your metric of success, whatever that was, and you see, great, all of my measurements are above the line or below the line, whatever the criteria is, just max or min, right? And you say, my system passes. And you look more carefully at it and you realize, yeah, all of my dots are above the line. However, 10 of them aren't very far above that line. Have I really seen all the variation I might see in mass production? And if I make more of these, if I make 10 times, 100 times, 1,000 times more, how likely is it that I start to get some points that are below that line just because of the natural distribution of things? That's what's called understanding how much margin you have to a target. So when you engineer something, yes, you want to set a target, but during the design phase, you also want to set sort of the design target, which is above the actual target by some amount to account for some amount of margin. And this margin is the methodology which you use to protect yourself from future variation that you can't possibly predict. And I've seen tons of times when you get to nearly the final build and now you're just starting to see things that are out of spec. And you say, what's going on? What's different? Well, the answer is nothing is different. You've just built more and you've now seen the total variation or more of the variation that it will exist throughout the lifetime of your product.
That's really good. Okay, 1A and 1B is really defining and understanding your requirements and how you're going to qualify those requirements. And then number 2, building enough of something so you have enough data points to give you a high degree of confidence that you have enough margin meeting whatever that specification is. Those are really great. Thank you. Okay, last question for you. So we talked about unforced errors and things that slow down engineering teams. How about the opposite? What are some ways that you've seen to accelerate the speed of engineering? And we're not talking about leadership coming in, cracking the whip, telling people to work nights and weekends. That we're talking about sustainable, legitimate acceleration, both at kind of an individual contributor level as well as like a leadership level. What have you seen that works for accelerating engineering projects?
Well, I think projects where you actually do 1A and 1B of our previous discussion really well, that accelerates it by virtue of the fact that you now know exactly what you need to engineer. So you don't have to spend a lot of time debating, is this good enough or not? I feel like engineering teams spend a lot of time debating whether or not something's good enough, where if you clearly spell that out, you don't have to debate it anymore, right?
There's a number.
It's there, right? And it can be revisited, but not spending too long, informally dwelling on it. Okay, do you have the data to say we can't meet that spec? Well, let's go have a meeting and let's go discuss that and let's evaluate your proposal. Can we change the spec or not? That's one of them. Good design review methodology, right? That will, in design reviews where everyone can learn from each other, where no one's there to ascribe blame or no one's there to poke holes in your thing to show how smart they are, but everyone is there to do 2 things. One, contribute to the goodness of the end product. Even though it's not your module, you're going to help your partner make their module better. And 2, learn from whatever it is they learn, right? If they made a mistake, if they did the thing you just talked about where they drilled and tapped a hole for a certain size bolt, but a different bolt is in the bomb, well, that should be your signal to let me go back and double check that. Right? Humans make mistakes. And then let's take that one step further, creating checklists, in the absence of the AI that you and I both want to arrive, creating good checklists, which error proof human tendencies. Humans will make mistakes. How can we ensure that they don't happen? There's a great book. I think it's called The Checklist Manifesto. And it's all about how checklists have taken error out of things like flying a plane, field of medicine, etc. And it totally applies to engineering.
I love that book. Yeah. Anyone who hasn't read that book, The Checklist Manifesto, do so. We have so many checklists. Well, not so many. We have an appropriate number of checklists at Pipeline. And I think it's one of the things that really does keep us on track is having that checklist to go through. Okay. Well, Jim, what a delight and a pleasure this has been. Thank you so much for sharing your valuable time with us and your immense wisdom and experience in product development and engineering. How can people get in touch with you?
I'm on LinkedIn. You'll find me under James Cuseo. that's really the best way. It keeps everything efficiently. You'll get lost in my spam filter there, or in my emails to the soccer team.
Perfect. All right, Jim. Well, thank you so much again for being on the show.
Cool. Thank you for having me. This was a lot of fun.
I'm Aaron Moncur, founder of Pipeline Design and Engineering. If you liked what you heard today, please share the episode. To learn how your team can leverage our team's expertise developing advanced manufacturing processes, automated machines, and custom fixtures, complemented with product design and R&D services, visit us at teampipeline.us. To join a vibrant community of engineers online, visit thewave.engineer. Thank you for listening.